So from Unit 3, let's recap the concept OOPS, object-oriented programming concepts, in which we have the features of OOPS, class definition, what does it contain, like data members and member function, then constructor, the object, how do we create an object, how do we access our data member function, inheritance, polymorphism, and types of inheritance by types of polymorphism, like that. So let's see each of this. So what is object-oriented programming? It is a fundamental concept in Python so that we can build some modular, maintainable, scalable applications. Okay. So it makes our code easier to write and it will organize our code better in a better way. So it organizes the code using what? Classes and objects. Okay. So it represents real world entities and its behavior. So in OOPS, we have something called as object that has attributes that have specific data and it can perform some specific actions using methods. So what are the advantages of OOPS? It encourages modularity, reusability, flexibility. It will pro- properly hide our data and information, then it will maintain our data, etc., etc. So what are the features of OOPS? We have a total of 6 features, namely classes, objects, inheritance, polymorphism, abstraction, and encapsulation. So OOPS, what does it do? It organizes our code into classes and objects. It supports encapsulation. It enables inheritance. It allows polymorphism, and it improves our modularity, scalability, and maintainability. So let's see each of these one by one in detail. So why do we first we will go for classes and objects. So why do we need classes and objects? So Python's allows you to model real world entities in code using classes and object, the same thing. So it supports OOPS for by using reusable templates, namely the classes. So classes are the templates, or in a way we can say blueprint, in by which we create a blueprint or a template of some particular structure, some template, so that we can use it. And we also have something called as objects that are real world models. So it promotes code reusability, it promotes modular design, and it organizes our methods and attributes. Whatever functions we usually use, right? It will organize it in better way. So we will group the related data and behavior so that we can uh, simplify our complex programs. So it have some key concepts like inheritance, encapsulation, and polymorphism. So what is a class? Again, it is a user-defined template for creating some objects. So it bundles data members and member functions. So data members are also known as class variables. Data members are also are the variables. So there are 2 types of data members, class variables and instance variables. We will see each of these in detail below very soon. So what does a class contains? First, let's see. It contains data members and member functions. So for an object, it acts as a blueprint, so using which we can create multiple instances or multiple objects for using that. So um, we can create one or even more than one objects from a class. So let's see, how do we define a class? We define a class by using class keyword, and see, this is the example for this class, class name followed by a colon, under which we have a variable x equals to 5 and we are trying to print. Okay. So we have seen that a class bundles data members and member functions. So we have two types of variables in as in data members, like class variables and instance variables. So what are the class variables? So these are the variables that are shared across all instances of the class. So it is defined as at the class level outside the method. Okay. So all the objects of class can share the same value for the class variable. Okay. On the other hand, the instance variables are unique for each instance, and these are defined inside the instance methods. So instance variables are defined inside the methods, instance method, that initialize method, and class variables are outside the method. So its value will be same for each one, but value of instance variables can differ. So for example, see, species is a class variable. On the other hand, this name and age are instance variables that can differ. Name can differ, age can differ, but species is the same all all over the class. So next we have member functions, something called as member functions. In like it is also known as methods or a member function. So what is the difference between method and a function? Let's see. A method is a function that belongs to a class. It define it's defined within the class and operates on instance of that class. So method is defined inside the class, whereas the functions are independent and these are defined outside a class. Okay. Whereas again, the method belongs to a class, are called on an object and are defined inside the class, and it also have parameter called as self parameter. So we also have initialize method. All classes have a method called init initialize method, which is always executed when the class is being initiated. So this method is what is its use. This method is used to assign the values to object properties or other operators necessary. So this is the kind of default one. So see, for example, this one over here. So this assigns the values to our objects create. See over here, initialize method initializes name and age attributes when a new object is created. There's one more thing, as I mentioned about self parameter. Self parameter is the reference to the current instance of a class. Okay, it allows us to access the methods and attribute of that particular current object. There's one more method, that is string method. String method controls what should be returned when the object is represented. Like, for example, over here, see, we're defining string. So what must be returned? It will represent like string. It will return some string. See, if the string method is not set, the string representation of the object is returned. Next, we have a construct, something called as constructor. In Python, the term constructor usually refer to this method itself. So this is the special method that's automatically called whenever you create a new object. Whenever we create a new object, this is the default method that is called by its own, and its primary purpose is to initialize the objects. So what is an object then? An object is a specific instance of a class. So it will have its own set of data. Class is just a blueprint या फिर एक template है वो. But object will contain it its own set of data values, as we have seen in our slides, if you remember. So class is a blueprint, whereas the object is it has its own state and behavior. For example, class can't consume any space, but objects can consume some space. Take this as an example. Class as a blueprint of a building or some house. Okay, so that is the structure, something, some structure, some template, some blueprint. But the actual thing is the object, the real entity that takes up the space is the object. This class will be just the template, the blueprint, but the object takes up the real memory, real space. Okay, so objects are the real entity. It has its own state, its behavior, and properties, whereas the class is just a blueprint, a template that is the collection of data members and member function. Also, a constructor that is initialized constructor. We have seen the advantages, the four pillars, what are the features of OOPS also. So let's continue with our objects. So so each object will have its own attributes and methods, and an object is also called as instance of a class. And when we create an object, that process is known as instantiation, and the memory is allocated whenever whenever an object is created, it gets allocated with memory, some space, and every object can be identified with a unique name. Okay, and one object can interact with other objects. So what is the syntax for creation of objects? The object name equals class name argument. This is also a constructor. Okay, now object name. Object name can be anything. You can assign anything, and you can assign any name. The class name must be same as the class name, as the name suggests. Class name is the class name. So this is also called as constructor, default constructor. So let's see an example. Class dog. Class name sound equals one. So this is a class, simple class in which just the one data member or variable is there. So we are trying to create the object for this class. So our object name is dog1 equals the class name. Class name is same as this dog, right? That is how we create our object. Now we are trying to print the sound. So how do we access this sound variable is inside that class. So how do we access that particular variable? We can access it using object of that class. So what is the object name of that class? Dog1. So we are using dog1 dot sound. Okay, so that is how we are accessing the variable of the class using what? The object. So this is how we created it. This is how we accessed it. How did we access it? The object name dot operator. This is the operator. Then the variable name, whatever you want to, variable or function you want to access. So how do we access? Again, in detail, let's see. Accessing data members and member functions. So how do we access a data member? Object name dot attribute name. Just now we accessed it, right? Dog1 dot sound, like that, dot, using dot. Then again, in place of some variable, if we have some functions, then the same thing, object name dot the method name. Done. So that is how we access our data members or member function. That is all about classes and objects. Now let's see what is encapsulation. So encapsulation is an essential aspect of object oriented programming. As you can see the picture over here, this is a capsule, and it is, what is it doing? It is combining our, yeah, for wrapping our code and data together into a single unit. So what is our class containing? A method and our methods and our variables. So it will contain our related methods and related variables. All right. So that is known as encapsulation. So we don't have in-depth thing in our syllabus, but I'll again tell you, in encapsulation, the methods and variables can be of different types, like private, protected, and public, so that we can um, we can use it uh, against the data misuse. We can It can help us to like guard our data misuse. Unauthorized people can't access our data, our methods, and our variables if we private it, like that things. So like we have different access modes, like one is public, second one is protected, third one is private. Okay, so which prevents unauthorized access to our objects. Okay, and it guards our data misuse. So that is how it works. See, we can make our methods and all private, etc. If we want to make our things accessible to everyone, we can make it public, like that. So that is all about encapsulation. In short, it is a wrapping of our methods and variables in single unit. Next, we have something called as abstraction. Abstraction is used to hide the internal details and shows only the functionalities. We have seen some meme example during our classes. Encapsulation was झुंड बनाकर के चलो झुंड बनाकर चलो, like we are bundling it into a single unit. Our classes and objects, we are bundling our classes, methods and variables, we are bundling the class in which we bundle our variables and methods. Now, abstraction. Uh, Abstraction shows only the essential details and hides unnecessary information. So only the things, like suppose you have your phone, you can't see your motherboard and etc etc. It will be covered with something, right? We can't see the inner components. We are not concerned with that. And you have your car, it is covered, right? Its engine, etc etc. What all are the inner parts of it are covered. So we will be able to see only the essential part. Rest of the things will be hidden. That is known as abstraction. So abstraction is used to hide internal details and show only the functionalities. That means it will simplify the complex system by modeling, and only essential features will be provided. So it can abstract the classes and methods. So we also have something called as inheritance and polymorphism. As we have seen in first unit, there is some concept called as dynamic typing. Dynamic typing means Python, our language, is dynamically typed. That means the type of object is determined at runtime. We won't write like int a equals to 10. That's how we don't do that like that. But um we write it as a equals to 10, simply like that. We don't specify the type of the object. So it will be determined at the runtime. That is known as dynamic typing. So next we have something called as inheritance. What is inheritance? Inheritance is a property in which one object acquires the properties and behaviors of the parent objects. So there will be a concept. We have a concept of class, right? So one class can acquire the properties and behavior of other class. So the class that is acquiring the properties and behavior of the other class is known as child class, and from which the class from which it is acquiring that is known as parent class. So see, for example, class B is acquiring the properties and behavior from class A. So that is this is the parent class and this is the child class. Similarly, this is the parent class, this is child. Then this is the parent, this is the child, this is the parent class. Like that. For example, see, a vehicle can be parent class, its child class can be a cycle, a car, a scooter, these are its children. So again, it is a concept that allows a class, that is child class, to inherit the properties, behavior, attributes, methods from another class that is known as parent class or base class. So parent class is the class being inherited from. It is also known as base class, and child class is the class that inherits from another class that is known as derived class. So let's see an example for this. Class animal. Suppose this is a parent class animal in which we are defining some functions. We also have class dog. So how do we inherit? What is the syntax for inheritance? We will write class, child class name, then under the bracket we will write the parent class name. If you can notice, this parent class name is animal, and while creating the child class we are mentioning it in under the parenthesis. So that is how we inherit the parent class to a child class. Okay, so we have object of this child class d equals to dog, under which we are giving some name to the dog, that is Buddy, and d, using d, the this is the object of dog class. D is the object of dog class. Notice that d is the object of dog class, right? Now we are using d dot info. Is the info method present in this dog class? No, it is present in animal class. Info. See, info method is inside animal class. Still, we are able to access it using the child class because we inherit the methods, whatever methods, variables, whatever is present in the parent class, we are able to inherit in child class using this syntax. So whatever is there in the parent class we are able to access over here. So d dot info, see, inherited method. There are 5 types of inheritance: single inheritance, multi-level, hierarchical, and hybrid. So in single inheritance, there will be a parent class, then there will be a single child class. So one child class will derive the properties from single parent class. But in whereas multiple inheritance, a child will derive the properties and attributes from multiple parents. For example, parent 1, parent 2, parent 3. The child will be having all the properties and behavior or methods from all the parents. Now we have hierarchical inheritance, in which one parent will be there and multiple child classes will inherit from a single parent. Now next we have multi-level inheritance, in which we will have some parent class, child one, child. We have multiple levels in a way. For example, you're a grandfather, then father, then you, like that. So child one will inherit from parent, then child two will inherit from child one. That are the different levels. Lastly, we will have hybrid inheritance, that can be a combination of any two or more combination of two or more any types of this inheritance. For example, here only this part is which inheritance, hierarchical, and the second below part is multiple inheritance. So this is hybrid inheritance, the combination of two or more types of inheritance. So single inheritance, same again. The class person, for example, person is the parent class. We have child class employee. Employee is trying to inherit the behavior, properties, attributes from the parent class. Single parent class, single child class. Now when we are creating emp for the this employee class, we are able to access employee dot name, that is present over here by using this method only, because we inherited. Then we have multiple inheritance, in which we will have multiple parents. For example, parent 1, parent 2, child, a single child will be acquiring the properties from multiple parents. This is the syntax, this is the example. So, multiple parents, for example, person is a first parent class, job is the second parent class. Now, third parent class, that is child class, is third class, that is child class, is acquiring the properties from first parent class and second parent class, that is person comma job. Now we have multi-level inheritance, in which we have multiple base classes but one child class. Multiple levels of classes. Like suppose we have first parent class, then employee class, second class is acquiring some properties and behavior from first class, then third class is acquiring from second class. That is the levels, multiple levels. Like it will go like chain. This is acquiring from this is acquiring from this, like that. It will go like chain wise. So your grandparent, then your parent, then you, like that. Then we have hierarchical inheritance. That means we will have one parent and multiple children. For example, we have a person class. Okay, that is a parent class. So child class 1 is acquiring the properties from that person class. Child class 2 in turn is acquiring the properties from parent class. Both the classes are acquiring from the person parent class. So that is about hierarchical inheritance. Lastly, we have in hybrid inheritance, in which we can have the combination of any two or more in types of inheritances. Lastly, we have something called as polymorphism. Polymorphism means multiple many forms. It is an ability of a variable, a function, or any object to take multiple forms. For example, you can see in the example of her. So there are two types of polymorphism. See, an object can take multiple forms in Python by enabling polymorphism enables that. So types of polymorphism: compile time and runtime. So compile time polymorphism has method overloading and operator overloading, and runtime polymorphism method overriding. Remember this. So first one, compile time overloading. So we can overload our methods. Basically, in Python, true overloading is not supported in Python, but still we can implement it using default or variable arguments. That is, we have seen those concepts in our first unit, right? So see, there is a class calculator in which there is a method multiply. Okay? In multiply, if you can notice there are some arguments: self, comma, a equal to 1, b equal to 1. These are the variable default. These are default arguments. So we are trying to use this multiply in many ways. How? See, using default arguments. See, we created an object calc for calculator dot multiply. So we are accessing this method multiply. Now, when we are not giving any argument over here, it will take 1 and 1 equal to 1, b equal to 1 as its argument and return the result 1 into 1, like that. If we give one argument over here, it take 1 from the default and 4 from here. So we are able to use this in multiple ways, as in without with zero arguments, with one argument, then see with multiple arguments like 2 and 3, then 2, 3, 4. So that is how we are able to use this particular multiply um, method in many ways. In many any number of arguments we are able to use. That is how we are trying to implement method overloading over here. This multiply is a method. We are trying to use it in many ways. Then we have operator overloading. We can take a simple example of a plus operator. Plus plus can be used as addition operator like 5 plus 10, 15, or it can be used for concatenating or joining some string variables like hey data science like this, or it can also concatenate a list like this 1 comma 2 3 comma 4 concatenation. Lastly, we have runtime polymorphism. It is also known as overriding. So previously, while doing overloading, method overloading, we were trying to use the same function name with different arguments, right? The function name was same. We were using different arguments. No arguments 1, 2, 3 like that, right? One function name, one method, different arguments. Remember that. But over here, everything will be same, like methods will be same, method name will be same, and the arguments will also be same, but we will override it. How do we do that? See, it is an ability of any OOPS language to allow a subclass to provide a specific English. So what do you mean by overriding? I'll show you. See, we have this animal class over here. In that we have sound function, right? It has something called as some generic sound, but all the animals cannot have the same sound, right? So in by when we created another dog class and we inherited animal over here, now we are trying to override the method. See, the method name is same, sound, defining sound self. Method name is same, but the body of the method is getting overridden. That is the thing. So it is returning some generic sound, but inside dog class it is returning what? Bark. But cat can't bark, right? Dog can bark, but cat can't bark. So again, when we are defining the sound method, sound, self, the same method name, same argument, but the body of the method is different. Here it is bark, here it is meow. Like that, something like that, we are trying to override our methods. So method name as well as the method arguments are same. See, method name, method arguments are same. The body of the method are different. In overloading, we have method names as same, but arguments are different. We try to implement using different arguments. That is method overloading. This is method overriding. Okay, that is all about OOPS.